Hello, everybody. Oh, okay. Hello, everybody. First of all, my apologies. It was a bit of a misunderstanding because I was thinking we were using Teams, but we had to use Zoom and I had to install it first. So it took a little bit longer, but that will not be a problem because I am definitely sure that I will end in time. At least I keep track of time. Thank you for being here, being online. For me, this is the first time I have the opportunity to talk to you and teach you about data modeling, a very important aspect in the field of data and analytics that I will shortly tell you more about when I introduce myself also. For now, let's make it an interactive session if you like. So if you have questions, feel free to bring them forward. I might not notice questions in time. Maybe somebody, maybe you, Parvati, can help me and break in and tell me that there is a question.
Sure.
Yeah, because what I don't know, to start with, is the knowledge of the people listening to this presentation. We arranged this on short notice, so we did not have really the opportunity to investigate the background of all the people in the meeting. So I have no idea if there is general knowledge about databases and data modeling in general. If not, let me know so I can maybe elaborate a little bit further, a little bit more in detail before I start about these topics. Otherwise, I assume that there is some database knowledge present in the group, and I can move forward on that so that people know what a database is, what tables or entities are, or what relationships are, because that is what I will be talking about. Let me close the door because it's a bit noisy. So that's better. So for now, I assume there is some knowledge of databases and systems where data is stored. This is my agenda for today. First of all, I will talk about myself, introduction. Then I will tell you something about an evolution that we saw over the years in information modeling. Then I will dive deeper into 3 types of modeling that are used widely in the data and analytics space. And at the end, I'll have an overview with all the advantages, disadvantages of each of the modeling paradigms. And of course, again, what I don't know is that we use these various kinds of data modeling in our practice. Some people need to have knowledge, need to be very knowledgeable about these modeling concepts because they have to build solutions, large data platforms, for instance, and know how to model them. But on the other hand, there are also consumers of data, users of data, and for them, it is very well. It's good to understand what data engineers go through, what they have in mind when they develop and design big data platforms. So at least you have some understanding of the data modeling concepts that they use. So in conversations, you can talk about it. So that's my goal with this presentation. So on the one hand, you could use it as a starting point in becoming a data engineer. On the other hand, it is worthwhile because it'll smoothen your conversation with data engineers and people that deliver data platforms. So you better understand where to look for the data and what you can expect in terms of data models. A little bit about myself. This is me. I reside in the Netherlands, in the south of the Netherlands. The Netherlands having the capital Amsterdam. I'm saying this because there are still people out there that think that Amsterdam is the country, but that's not the case. It's always funny to hear. Well, I live in the south, 1.5 hours drive from Amsterdam, and there I have a company called Nippur, as you can see on the logo at the bottom. And that's where 25 consultants are working on delivering data solutions to large and multinational companies in the Netherlands. So we are very locally focused. I myself, I studied information management at Tilburg University. I graduated in 89, and I've been a consultant since 1992. Initially for a large system integrator, but in 2002 I started my current company Nippur. I've been doing that for almost 30 years now in all kinds of roles. My main roles are a data and analytics strategy consultant. So I help companies in becoming more data driven. I'm also involved in business development. I always see opportunities and I want to link those opportunities, also combine companies to make them better, to make them smarter. And I'm good at program and project management. So as part of this program, I sincerely hope that maybe someday, somewhere in the world, somebody says, hey, Peter, can you help us with a project wherever? Because I would like to travel to the regions in Africa, Asia, South America, wherever needed. But okay, apart from that, I'm an incubator of Sonar Records, a record company, Refugee Friend, an app that I developed and I rolled out worldwide to help refugees find refuge when on the run. In Europe, that's quite a problem, and they are quite in danger. And with this app, I want to provide them safety while traveling to friends, family elsewhere in Europe or elsewhere in the world. That's about me. We're going to talk about information modeling. Information modeling is all about an abstract formal representation of data in terms of tables, entities, and relationships, and the operations that can be performed on them. It's a way of capturing the data in such a way that in an optimized way for a certain purpose that I'm going to talk about in a few moments. And there is not one size fits all. There are various modeling paradigms, like I said, and they all have their focal point. Because the choice of the data model, as it says, has great impact on the flexibility and the performance of the data architecture. Because in the end, people are building data architectures, and they consist of many layers. In my presentation, I will show you examples of architectures as well. Although there will be another course we will teach on the evolution of data architectures and the layers involved. But within these layers, that's where you use different modeling paradigms. And you have to choose the right paradigm. And what you need to do is you need to transform your source data models, because many data comes from source systems. And nowadays that's huge, that's enormous. Traditionally, those were only the systems that companies had in their house, the systems that support the operational processes. But nowadays, data comes from everywhere. But these we consider all source systems. And you need to transform the data from these source systems to a data platform and bring them together in such a way that it can be used for analytics quite easily. And of course, we have seen a growth in data over the years. It exploded. Actually, in my career, when we were loading megabytes of data, we thought that was much. But today we're already talking of in terms of petabytes of data platforms hosting petabytes of data. And now even people mention things like yottabytes and zettabytes. Now you can look it up on Google how much that is, but that's amazing. People in my field of play, busy with data analytics, have been thinking about data modeling techniques, because the traditional data modeling technique that originated a long time ago, what we call third normal form, was used to build relational databases for transaction systems. And they are not fit for analytics. I will explain in more detail a little bit later. Nowadays, we see also new database management systems enter the market. And even we see systems that no longer require data structured in tables. I will not elaborate on that. That's a different story. In most cases, we then talk about unstructured data like video files, audio files, text files, images. Also, they can be stored nowadays quite easily in very specific structures. But I'm going to focus on more structured data and the way we model those for analytics. The good news is that originally, the 5, 6, 7, 8 years ago, the big data arena exploded. There was this implementation of let's say the coming to growth of companies like Facebook and Google and Yahoo, etc. And they required a different approach in data storage, and they invented these non-database oriented data platforms. A term they use, but you can forget it, is Hadoop. The Hadoop, the Apache family of technologies. But over the years, vendors have developed tools to make that way of storing unstructured data and structured data resemble the way we were used to look at data through entities, through databases and tables. So it became familiar after a couple of years. So even today, although size has grown enormously, we can still talk about storing data in terms of data models that we used to build 10, 20 years ago. So it's in Dutch we say it's old wine in new baskets or so, or buckets. I don't know if that's an English saying. First, let me start with showing you a very high level data architecture. Typically the things that we build when a customer asks us to develop a data platform. It's a very simple visualization. On the left-hand side, you have the data that you want to retrieve, you want to connect to, you want to collect. We call that data input, and we call that the sources, the source systems. And that can be anything. So that in most cases, those are databases, but it can also be like what I said, like video, audio, text files, all sorts of APIs that are there that you can connect to. People nowadays are even crawling websites to retrieve data. It's amazing to see how many sources there are and how easy they can be connected. The second layer, which is which color is it? Light green, yellow color in this picture. It's what we call the data storage area. That's where we store all the data all the time. And that requires a specific data modeling paradigm that I will talk about later. But this particular layer is the layer where all the data is stored, consisting of all the history. Even if the source does not deliver history, because data is changed, because it's quite normal that in a source system, data is updated. Many source systems don't keep track of changes. We do. So in this second layer, you can model that so that even if something is changed in the source, it is captured in this second layer. And what we do in this layer is we build up history, and we build up and we realize integration. Now, history means, this is an important requirement. History means that you can always, what we call travel in time. So you can always go back to previous situations. Give you an example. Somebody is paying for his healthcare, so he can benefit from being treated in a hospital if he gets ill. But a person moves. Somebody lives at a certain address and decides to move to another address. The fact that a person moves is a change. It makes it relevant to not forget where this person lived before and where he's living now. So in this layer, we keep track of that, and we have data models that support that. Thus, an analyst can also see if this movement of living in another location has impact on healthcare that this person needs, on healthcare costs. Did he move to a better environment? So he got healthier. I don't know. For analytics, it can be very interesting. Now, this layer contains all the data all the time, but I can tell you, usually it's a very complex layer in terms of data modeling. So what we do next is that based on business requirements, so based on requirements from the analysts, the people that want to consume the data, we create subsets from this huge database. And that's the blue column. We call it the information delivery layer. So there we build structures where we only deliver the data that you need for your analysis. So that's maybe 5% of the data in the previous column. And it's also matched so that you can quite easily consume that data. And for that, you require a different modeling paradigm. And I will tell you about that in a second. And then in the red area, that's the information consumption taking place. So that's where tools are being used like R, Python, Power BI, ClickView, what have you, whatever people like. That's where the reports and dashboards are built. Luckily, after all these years, we've been able to automate this whole process in collecting data, storing the data, and preparing the data sets for data consumption, making you less dependent from consultants, because that was a bit of a problem in our area. There are many people, they know how to build this kind of architecture, but the moment they leave, there's nobody to support nobody to do the maintenance and to support extension. And I always say there's a graveyard of data platforms out there because of people leaving. That's very sad. But if you can automate it, at least you have some tools in the market that always generate the same code, the same kind of data modeling. So you can always continue expanding your data platform, because that's what data platforms do, they grow. Now, what we also see is that most platforms now reside in the cloud, which is also quite common. And in our case, 99% of our customers, they use Microsoft Azure. Now, here is the evolution of, somebody's waiting to enter. So the evolution of data modeling. Initially, long time ago, in the 60s of last century, there were people like Cott and Date. They invented the relational data model called third normal form. And that was primarily meant to build the operational source systems, the systems to support business processes, like a customer management system, an order management system, production systems, what have you. Over the years, we found out that that's not a neat modeling paradigm to do analytics. I will explain in a moment. So in the 80s, people made some adaptations to this modeling principle to adapt it for data platforms, what we call data warehouses. Also around that time, star schemas were developed, and I will elaborate on those. And in the 90s, a person called Dan Lindstedt, he invented the data vault concept to be able to store enormous amounts of data. And I will explain that as well. I will elaborate on each one of them. And by the way, data vault has also a sister modeling concept. It's called anchor modeling. I will not elaborate on that. You can look it up, but it's very complex. And I'll warn you, because I will warn you also when you want to implement data vault. It's rather complex, although very powerful. But anchor model is even more complex, but it's ultimate flexible. If you understand data vault, you will also understand anchor modeling. Okay. Now, information modeling, data modeling is all about what fits your needs. And this is also always a nice picture to show. Which bike would you prefer? And of course, I think most people would choose the bike on the top. But in this case, of course, this is a trick question, because your question should be, what's my underground? And if this is your underground, you choose the bike with the square wheels, because that better fits your needs. Well, this depicts very nicely how you should look at information modeling, at data modeling, if you want to handle data. It's precisely what we're going to talk about. What data modeling paradigm do I need for what kind of problem? What problem do I want to solve? That's what this is all about. What we want to achieve for BI or for analytics, business intelligence is a bit an old term. It became an old term over the years. But for business intelligence, data warehousing, we have some requirements. Of course, initially, what we always want, we want to be able to grow. You don't capture all the data at once, but new sources arrive quite regularly, and you want to connect them to your existing data platform or to your existing analytics requirement. So it means that your data modeling concept should be able to grow. So it can follow the demand-driven approach, and at least it should not cost too much to modify the existing data model, because if you have to adapt, change an existing data model, when it becomes more and more complex over time, in the end, you could end up with a data model that is so complex that you better start anew. And usually that's a disinvestment. In the Netherlands, we have seen this happening, where people have invested like 1 or 2 million euros in the data platform, and then they had to start all over again because nobody understood the data models anymore, because they became rubbish over the years. That's not what you want. Of course, the data model has to support you in being able to store all sorts of definitions, because master data definitions are also stored in the data platform and need to be extracted. You want to be able to have subtle variations in definitions, things that seem the same but are not the same, depending on the context. What I mentioned before, you want to be able to register data in its historical context. So not only, of course, transaction data is always historical. So for an example, my energy consumption today and my energy consumption tomorrow, is automatically historically relevant, because what happened yesterday will never change. But here we talk also about history in terms of the descriptive data surrounding the facts that you measure. So where did I live? Where did I consume this energy? Where was my house? And today I live in this street, but tomorrow I live in that street in that city. And that's a different kind of history that you also want to keep track of. And of course, last but not least, you want to be able to implement privacy and information security rules. We've seen that over the years that data has become more and more important. So you want to have structures in your data model that you are able to protect your data. And also legally, you're required to do that. We have the GDPR in Europe. America has some rules, some very strict rules in that sense. That starts with your data model. If you're not able to implement that in your data model, you're lost. I've seen data platforms where people forgot to do this properly. And in the end, it became impossible to restrict access to the data. There was nobody who could tell who had access or not. That's quite tricky. Yeah. So in terms of data modeling, in terms of realizing a data platform, we always say think big, but start small. So you can learn also, learning by doing, source by source. You should be able to build up your data platform. That's what we try to say. You have to design your architecture in terms of think big. So you have to design your layers up front, but you can start small with 1 source system, 2 source systems, to learn in your organization what works best for you. At this point, for me, it's quiet. I'm sitting here talking. I know there are 40 people online. I have no idea, but is everything all right so far? I have no idea if I can ask this question anyhow, but if nobody responds, I can assume that maybe that's okay. Oh yes, I see reactions. Yes, all good. Okay, thank you very much. Oh, that helps me a lot. We need more explanation on it, sir. That's Mukhtar. Maybe he can elaborate a little bit more what he needs, so I can have a look at it maybe a little bit later. Then I'll leave this little box open.
Okay, sir. The reason why I say you should explain further is that at the beginning you said if there are some people that do not have a lot of experience on it, they should speak about it so that you can explain in details. Mm-hmm. That's it why I asked, but I'm getting it now. Thank you.
But let me know if things are not clear. drop in. Thanks for your response.
Okay, sir, thank you.
Ik heb geen overeenkomstige locaties.
So, okay, let's start with the relational model. That's the oldest model we know of. And this is an example. And I'll explain. So if people have no knowledge whatsoever of databases and data models, then this could be a good introduction, because this is what we do, this is what we did in the past when we tried to build registration systems, database systems, in order to be able to store data while interacting with customers, for instance. Now, in this little example, we have a customer table, and in the customer table are all the customer details like address, name, etc. And as a company, we also, at the right bottom, we have a list of products that we sell. And of course, products can belong to a product group. It's a relationship, one to many. So one product group can consist of many products. And a customer wants to order a product. Simple as that. So what a customer does, he goes online, for instance, he selects 3, 4, 5 products. Each product becomes an order line on one order. So he has one order, and on one order there are 5 products. I think you all recognize this when you go to a shop. If you buy goods online, you have, that's what you get. That's also your invoice. It looks like your invoice as well. And in the end, of course, the customer pays for the order, and then everything is done. Now, this kind of data model is what we see a lot. If you go into operational systems, this is what you get. And then huge. In terms of tables, we are very used. I give you one example. There is a system called SAP. It's a German system. It's being used by large companies. They want to capture everything that's happening in a company. All the processes happening in a large company are being stored in SAP. And I heard people say that it contains like 12,000 of these tables to store everything that's happening. And that's what a company tries to do. To do that, the relational model, it originated a long time ago already. It was invented because there was a problem, because storage was very expensive. 10 megabytes, I still remember, could cost up to thousands in nowadays terms of euros to buy a disk. So what people didn't want was data redundancy, store the same data twice. So if you have a customer, like my name, Pieter Rambags, you want to store my name once and then give me a code, number 1, and then use number 1 in all the other tables where I intervene with that company, but not repeat my name, Pieter Rambags, Pieter Rambags, Pieter Rambags, because if you do that, you need a lot of bytes to store that. That's not efficient. You want to avoid repeating data elements. And also what you don't want is update anomalies. That means that, keep that in mind, if my name is all over the place and my name changes, a bit of a weird example, then you have to go through all the tables and not forget one, because if you forget one table, your database becomes corrupt. So that's typically what this kind of data modeling prevents. My name is only in one table, in one position, and if I modify that, or my address, if I modify that, it's good, it works everywhere. The database is still correct. And designing such a database is called normalization. And that's what's happening here. You have several rules. Each rule is called first normal form, second normal form, third normal form, etc. That goes on, and it becomes more complex along the road. Most source systems are in third normal form. For you, it's not so relevant to know how to do this. If you want to know it, there is a website I added a link here. It's in Dutch, but if you use Google, you can translate the text. But it shows you a very nice example of how it's done on live data. It's a record store they use as an example. That's always a good example because everybody knows about records and music and loves music. If you go through it, you understand what normalization is and what they do to avoid redundancy. And this was invented by these people like Date and Cott in the Americas in 1960. And what it says here on the left-hand side is that there's one thing is very important, is keys. And I'll elaborate on that further, but there is one aspect in terms of data that's very important, is identifying the proper business keys in an organization, because it's the key along which you align the data. So in terms of let's go back to customer data. My name, Pieter Rambags, for instance, I'm a customer. It could be that there is another Pieter Rambags in the world out there. So my name is not unique. And that could be, I know there is one, by the way, although my name is quite unique. But there is another guy alive who has the same name. If he becomes the same customer at the same company, then that company has a problem unless he provides a meaningless key to us, giving me number one and the other Pieter Rambags number two. Then that problem is solved. We are unique at that moment in time. Another solution could be to add my birth date, for instance, because the chance that we were born on the same day is very small. However, that could become an issue when my name is not Rambags, but Jansen, which is quite a common name in the Netherlands. There are tens of thousands of people with that name, and then that becomes tricky again. But if you go to this link, you can have a look at it and learn a little bit about how traditionally databases were set up. Now, what's a strong feature of relational models is it's very highly structured. If properly normalized, then data consistency can be guarded. So you only have to update at one location a certain data element, and everything stays in sync. You can still handle, and even nowadays, I would say it's less of a problem, large amounts of data, because what happened also, of course, is that processing power, compute power, and storage, that's no longer an issue. It became cheaper over the years. In those days, when this was invented, storage was expensive, compute was extremely expensive. So this relational model helped in saving a lot of money. Nowadays, we've become sloppy because we can, if we don't normalize the database very well, it doesn't bother because it's not going to cost us extra. Yeah. But the most important purpose of this kind of modeling is it was designed for handling real-time transactions. You must imagine that people placing an order online, for instance, they are doing that every second of the day. Yeah, large companies, they store millions of orders nowadays on a day, and this kind of models is able to support that quite efficiently and fast. And these models are relatively simple to expand. However, like I said in this example of SAP, this German elephant, it results in many tables. And if you are a data analyst and you want to build queries to examine the data, that's not funny. If you have to go through 12,000 tables to find out where your data is, then if you build queries, you have to combine a lot of tables to connect all the data you need. And maybe nowadays it's not an issue anymore, but I've seen consultants in the past, they built quite heavy queries on top of such a system, and they brought the system to the knees. So they were running queries for reporting purposes, for analytics purposes, but at the same time, people in the order administration, they were yelling because the system was slowing down and it was even coming to a stop. The customers could no longer order products, for instance. That's very dangerous. That's what you don't want. So that's why in typical data architectures, we download the data from this kind of model. We just extract it as is, and then we put it in the data platform. So we are not running the queries directly for analytic purposes on this kind of models. Let's see. Oh yeah, and in terms of analytics, what you also want is you want to be able to drill down on the data. You want to drill down over hierarchies, for instance, via product group to product to the order, or via world, country, region, city to a person. That's not easy in this kind of model. There are better models for that. And another issue, very important, and this is, let me see if I can explain that in detail. Because this is what we think is a big problem when people build or order these source systems, or build these source systems even. Most companies forget to model their company first. So before buying any software tools to support operational processes, you should first think of who am I? What is my logical business model? Because if you know that, it's more easy to derive the proper data model for your source systems. But usually they don't. They just start at the end. And by doing so, they make mistakes. So in many cases, the physical design of the source systems doesn't fit what the company is actually doing. And they always find out in the end when it's too late, and then they find solutions to work around it, but it usually misuses the source systems. And you as an analyst, you will be confronted with that. So if you dive into source systems, you will find these anomalies, these weird abuse of attributes in these source systems. Don't be surprised, it'll happen. And I think you already encountered this maybe. Marije asks, can you give an example of that? Marije, can you elaborate a little bit more what you mean?
Yes, well, I was talking about the last point, so the deriving from the logical business model, and it's quite hard for me to grasp what you're actually talking about.
Okay. Now, I'll give you an example. Let's take a bank, for instance. Everybody knows a bank. When you're a bank, every bank in the world is doing the same thing. So they don't have to think about it. They can even buy what we call a logical data model, which is a non-technical data model. It's not running in a system. It's not running on a computer. It's something you can print on the wall. You can look at, and if you look at it, you understand. Oh, I'm looking at a bank, because all the entities I see and all the relationships I see is talking about customers, accounts, mortgages, what have you, loans, percentages, interest rates, blah blah blah. It's known, and if you have this model plotted on the wall so you can look at it, we call that more a logical business model. If you then want to implement a new computer system in your organization to one of many thousands maybe, because like banks, they have thousands of systems, you better look at this logical model hanging on the wall to decide how you're going to model your new system that you're going to buy or to develop. Because if you don't look at that model that depicts your bank 100% accurate, and you deviate a little bit from it, you're in trouble. Does this make sense, this answer?
Yes, it does. Thank you so much.
Okay, thank you very much. So the relational model lays the foundation for all other models. It's the most common database concept, like I said, and it gets the job done for storing data, but it's not so good for analytics, as I said. Here comes a model that's very well known in our arena. It's called the dimensional model. It was a model invented to solve the problems with the relational model. Because what the dimensional model does, and I'll show you an example in a second, is it splits the data into facts and dimensions. The facts are the things you want to measure. So that mostly they are numeric values like quantities, prices, volumes, these kind of things. And the dimensions, they give them meaning. I give you an example. If I tell you 1,000, that doesn't say anything. You say 1,000 what? And when I tell you it's 1,000 of this kind of product, of this particular product, but then you tell me again, yeah, and then what? 1,000 of that product. What happened then? Yeah, sold to that customer, sold at that moment in time, sold at that price, sold by that sales representative. And then this 1,000 gets meaning. And that's what we mean by dimensions. So dimensions add meaning to data, to the facts. The dimensional model is also created while talking to the business, not the technical people, but the users of the data, because they're asked to describe their world. So we can model that in the dimensions, in the dimensions and the facts. So if you use a dimensional model, you will automatically discover that you have to transform the data in the relational model to make it fit. So you have to transform it to the dimensional model, but you'll understand in a second. The dimensional model is not 3NF compliant, and we accept a lot of data redundancy there. And that is also very beneficial, because by doing so, it becomes more easy for data analysts to understand and use the data. It makes your queries simpler and it makes your queries faster. This was a problem a long time ago when storage was very expensive, but nowadays with these huge cloud environments where storage is not the cost, we can get away with that. And also compute is not that expensive anymore. So the dimensional model is still very strong. It's implemented a lot, very close to the business users, to the data users. But I'll give you an example. Here you have an example. And we call this, in dimensional modeling, we call this a star schema. And if you look through your fingers, I hope you recognize a little bit of a star shape. In the middle, the core, and in the outer layers, the beams of light that drift away. In the middle, you will only find the numeric values, like the sales, for instance. And in the blue tables, you will find all the attributes that give meaning to this figure in sales. So in this case, sales could be, like I said, 1,000. But because I have in this sales table, I have extra columns with identifiers with keys linking to these blue tables. I can tell that these sales were sold in a particular store by a particular sales rep to a particular customer and of a particular product type. That's what we try to describe here. Most reporting tools on the market, like Power BI, ClickView, Tableau, they love this. Because when you have a model like this, they even detect the relationships if you insert the data in your reporting environment, and they automatically start drawing this kind of data models in their modeling environment. Because this is actually one of the most beneficial forms of data modeling. If you organize the data in such a way, it's very structured for a reporting tool, and it can report on the data very fast. Now you can extend this kind of modeling by adding another fact table. Now I have 2 fact tables. In this case, also I added some data on promotions. And for some reason, it's relevant to mention that promotions only take place in certain countries and in certain market segments, but it has no direct link with sales. The only thing it shares is the product dimension. So promotions are about products in certain countries, in certain market segments. So in this case, product, which was a dimension table, it becomes a conformed dimension, as we say. So it's a shared dimension in 2 fact tables. Now, typically these green tables, they become very big. They can be very, very, very large because all the details, what happened, are stored there. The blue tables usually stay very small because they usually contain all the descriptive data to give meaning to sales and to promotions. So this is what we call, then in this case, product becomes a conformed dimension. And there's another term that you see on this page, it's called data mart. Data marts can be linked and navigated, it says. Usually we use this kind of data modeling when we build, we call that a data mart or a data set on top of the data platform. So remember this data architecture I showed you with these colors. There was this, if I go back, I'll come back later on. I have a separate slide on that. Let's not confuse things at this moment in time. I can extend this even further, and then my dimensional model becomes no longer a star schema, but more of a snowflake. If in winter, when you look at your window, you might have seen the structures of snowflakes. In this case, again, I have 2 fact tables consisting only of numeric quantities like prices, volumes, amounts, what have you. With the blue tables being the descriptive elements giving meaning to the facts in the green tables. But, and I have some conformed dimensions. In this case, product group is used in 2 hierarchies. One from brand via product group to product to a fact, and one via brand to product group directly to the green fact on the right. But as you can see, this way, by calling it snowflake, it's only an adaptation of the dimensional model. It's just an extension. It's just we're extending the dimensional model, thus making it in the shape of a snowflake. What you see here in this example, is that something peculiar happens, because in terms of the product hierarchy, it gives you the possibility to add multiple hierarchies for your analytics, because that's what you typically do when you analyze data. You drill down over a certain dimension. And in this case, for this company, they have like two hierarchies where product is involved. One is called from brand, that's the highest level, via product group to product. But also they have like division, from division to product group to product. And I think I recognized Philips in this. A long time ago, we used to work for Philips a lot, and we based our examples on that company, because they had different product hierarchies for analytical purposes. One was related to product and then to a certain product group and a brand kind of orientation. But these brands were developed in what they called organizational divisions. They had consumer electronics, they had medical systems, they had domestic appliances. Those were more organizational structures where they grouped products in, and they also wanted to be able to analyze over that axis. So in this case, you see that this the model supports in doing both, being able to do both. So you have two hierarchies in one dimensional model. Now, typically dimensional modeling was used, well, a strong feature was it was designed for what we call then online analytical processing. It's an old term. Nowadays, we would say slice and dice, drill up, drill down, aggregating data over the hierarchy. Those terms are still being used. And if you look at all the products out there, even the products 30 years ago and products today, I'll give you some example: Business Objects, Cognos, if somebody remembers, or when I started my career, ComShare, it disappeared completely. But all these products over all these years have always been doing the same thing. They gave us the capability to slice and dice through our data and to drill up and down over the hierarchies. You might know of the existence of pivot tables in Excel. They have a similar behavior. If you organize the data well, you can do the same thing in a pivot table in Excel. Like I said, they give good query performance with large data volumes. And this is very easy to answer subject-oriented questions. Like I said, the current tools, reporting tools out there, they are looking for this kind of models. So they're easy to visualize, and it promotes a single logical view on all the data. But there are also some weak points. If you want to bulk load large data volumes in dimensional models, then it can become too slow. Because first you have to update the dimensional tables before you can update the fact tables. Because if you update a fact table with new data, with new dimension data, and the dimension data doesn't exist yet, the model will complain. It will say, hey, wait a minute, I don't know this customer yet. First you have to update or add the customer in the dimensional table before you can add facts of this customer or this product or whatever. And if there are data quality issues, you're in deep trouble, because there's a lot of data redundancy. Then you have to update a lot of data. And also, this model does not really like empty cells, empty rows. Data needs to be complete and cleansed before entering the model. If your organization change, for instance, or if you have dimensional changes, you're also in trouble, because you can almost delete your dimensional model and rebuild it from scratch, because you have made some changes to the hierarchies. And you need more storage, but then again, because of the denormalization, you're storing more redundancy. But then again, nowadays, I don't think that's a problem anymore. And it's not very suitable for very detailed operational data or data exploration. Data scientists usually avoid this kind of model. They start with this kind of models, but they will also automatically ask access to the underlying data in the more complex structures, because there they can derive all the details. Typically in dimensional models, sometimes also data is prepared and is aggregated upfront to fit a certain business requirement. So sometimes you don't get all the details. And for data scientists, they don't like that. They want all the nasty details, so they can really look for relevant. I forgot the word. No, I'm sorry. It's coming back in a second. Maybe I remember later. Data marts, it's also nice to know, was traditionally used also to build large data platforms. There was this guy called Kimball, and he said that the data platform or the data warehouse is a collection of data marts. Well, we disagree. Because of the weak points I just said, if you have a problem, if your data changes, if your organization changes, if your logical model changes, if your data structures change, if your business requirements change, you have to delete your dimensional model. You can start from scratch. That problem you don't have with a third normal form model. So we always said, no. We are not going to build the data platform using data marts, using a group of dimensional models. No, we want to use data marts close to the consumers of the data. So on top of the data warehouse, on top of the data platform. But we want to separate it, this kind of modeling, from the models that we use for storing all the data all the time, like I mentioned before. Because another serious problem is that if you want to put data in a dimensional model, you have to really transform it first from your source system to this dimensional model. And by doing so, you lose the link to your source system. You no longer can prove that what you are reporting on is actually linked to the source system. So to give you an example, when you skip storing the source data as is in your data platform, close to what it is in the source system, but you transform it on the run to a dimensional model, it's hard to convince formal organizations like accountancy organizations that you didn't corrupt the data, that you didn't molest the data. And that's what, in certain cases, companies you're not allowed to do that. So in a data platform, you always have to have a layer that resembles the source system. So you can always prove that the dimensional model you built on top of that is still based on data they can trust, because it's related to how it was in the source system. Even if the source system did not store all the history. Let's look at the time, 1 hour. Okay, we're still going good. Then in 1997, a person in America came with a very interesting concept called data vault. Dan Lindstedt, he found out that we needed a data modeling paradigm for being able to store the ever-growing quantities of data, because that became more and more a problem. For the first time in history, we saw databases come to rise of sizes like petabytes, and that was quite an issue then. How to do that, how to model that properly. And then Lindstedt invented data vault. And data vault is quite a strong modeling concept. It's complex, but it allows you to capture again all the data all the time when setting up your data platform. So this is used not for data consumption as is per se, like the dimensional model, but this is used for capturing all the data and storing it on your data platform. And he came with this concept of business keys. And this is something very important to understand, because if you're going to build a data platform, one of your challenges will be to identify the business keys in an organization. Typically, data engineers they dive into source systems and they look at the primary keys, for instance, the technical keys in a database, but that's not the way to go. Let's talk about customers. If you want to store data related to what you know about a certain customer in your organization, you need to know what makes my customer unique. Which attributes should I use in a combination to identify my customer as being unique? And I mentioned before that my name is not sufficient, like Pieter Rambags. There could be another one. And then Lindstedt understood this very well. And he said, no, before you start designing a data platform, first look at your organization, look at your business, how your businesses work, and try to identify these business keys, because they are important. Because when you build a data platform, they will be the core entities in your data vault model, where you can link all other data to. So I'll give you an example again. Let's look at me as a person. Two companies. One company is a commercial company, and the other one is a governmental company, for instance. I make that distinction because I'm going to explain why. This commercial company can only ask me for information about who I am, and they have to derive a unique business key, so they can identify me as a unique customer. Now, probably my last name, Rambags, with my birth date, and maybe the city where I live, could be a unique identifier. They have to check that for all the customers they have. And if that's the case, then they have a business key consisting of 3 attributes. When you're a governmental organization in the Netherlands, you're lucky, because most governmental organizations, they are allowed to use the social security number that we all have. In that case, you only require 1 attribute, which identifies me uniquely. So then my business key is only the social security number. But commercial organizations are not allowed to do that. It makes it more hard for them. So they have to be very careful. Now, this goes for everything, not only for your customer, but also for your product. What makes your product unique? Which combination of attributes makes a product unique? So you know that in all cases, when you store data about this product, you know that you're not confusing one product with another, because that's what you don't want. But the same goes for production items, machineries in your companies, your employees, all objects residing in your organization should be identified properly. Now, this is hard. We noticed over the years that there's hardly any company that has ever done this before. So if you've not done this before, if you're not aware of how this works, then you should not start using Data Vault immediately. And I'll give you an example what we are doing now. But if you know this and you're aware of this, you can grow over the years, and in the end maybe build a Data Vault model. But you can start with a Data Vault Lite model that still has some of the benefits, while you're still learning what are my business keys. And now I will explain how you build a Data Vault model. But it's a very agile model, because it allows you to grow. It allows you to really start small, capture a lot of data, load the data in parallel, not like the dimensional model, first the dimensions and then the facts. No, all the data can be stored in one go. And nowadays, with these cloud systems, that's quite a strong feature. Now here again, I have this example that I showed you before. This customer and ordering a group of products that appears as order lines on one order, and we have this product catalog and product category. Now, the first step what you do when you start modeling a Data Vault model, you're going to look for the business keys. So in the case of the customer, I want to know what makes a customer unique. In case of product, I want to know what makes a product unique, a product category, and the order. A product catalog and an order line, they don't have business keys, because they are typically the result of the fact that the customer is allowed to select a certain amount of products from a product catalog. So a product catalog is built up of a list of products that are available to me as a customer. So product catalog is what we call a link in this case, whereas product, customer, product category, and order are business objects. Once you've done this, you could model it like this. And this looks maybe a little bit peculiar, but again, we're talking about a database. So all these things you see here, these 3 things, the hubs, the satellites, and the links. The hubs are the yellow circles. The satellites are the red squares, and the links are the diagrams here, the blue diagrams. They're all still tables. So if you look in the database, they are just tables, except we give them a shape here to separate them and to identify them. But what happens in this case is that, for instance, if I know the customer business key, I can create a very small hub consisting only in this case of my last name, my birth date, and my city, maybe, in my example, and an extra key. And what we also add in the hub is the date that I was entered for the first time. So when I became a customer is stored in this table as well. And maybe some changes, some change dates, change attributes. But that's it. So typically the hubs in this case, they are usually very small tables, but they are very long. Small but very long tables. The satellites, those are the tables that contain all other data about me. So for instance, I have a customer in Eindhoven. They have 7 source systems, and I could be buying products from each of these source systems. They develop these source systems over the years. They're not happy with it, but that's the case. That's how it works. But if I order various products and for some reason as a customer, I exist in all these 7 systems, then in their case, they could have 7 satellites surrounding me where they have information about me stored in the satellites. It's not optimal, but it's doable. Now, of course, most organizations have many source systems. So one of the reasons of having many satellites is that I reside in many of these source systems. Another reason to have more satellite tables is that sometimes it's convenient to split. This is an architectural decision, but I give you an example. Suppose I exist as a customer in a source system, and this company knows like 50 or 60 attributes about me. They know a lot about me. I interact with that company, but of these 60 attributes, only 5 attributes change weekly. The rest stays stable. Then in that case, you could decide to put the 55 attributes in one satellite table and the fastly changing attributes in a separate satellite table. So it also becomes more easy and convenient to have a small table updated regularly and one table that stays fixed over time. These are all design choices that you can use. The nice thing of a data vault model like this is that when I connect a new source system, like a payment system in this case, all I have to add is a link to my existing model, and I can add a payment hub and all the data I know, all the attributes I know related to this payment. So I can grow quite easily. I can set this model up once and over time gradually grow to make it become bigger and more complex. I can also add new satellites. So for instance, in this case, there's a new product category added on the right side because I added a new source system that identified a new product category that I didn't know before, maybe, or some attributes, sorry, about the product category that I didn't know before. So this makes the data vault modeling concept very interesting for storing large amounts of data. And this paradigm is something you could encounter when doing analytics and talking to data engineers. It could be that you find this kind of modeling in data platforms, because more and more people worldwide start to understand that this is a way of data modeling that will not result in 5-6 years in having to delete the whole data platform and start all over again. Data vault allows you to continue growing because it's based on the idea of adding instead of replacing tables and attributes. So data vault is based on well-defined business keys. So you have to understand your business very well. It's not technical. It's very suitable for enterprise data warehouses. There's large data platforms. All data is stored in time series, including the relations. It contains all the data, and it also supports data exploration. So this kind of model is a model that even data scientists sometimes like, because if the dimensional model doesn't fit their needs, at least they can go in here and start to understand what the hubs are about. And if they understand the hubs, they know where to look for the satellites and look for the relevant data. It's a fixed structure. It grows according to a very fixed set of rules. So you can't turn it into a mess. It's impossible. And the good news, it's not mentioned here, but there are more and more tools on the market that generate data vault models by reverse engineering source models. And you can load data in near real time and bulk loads. But especially near real time becomes more and more important because more and more companies want to report almost every second of the day what happened 3 seconds ago. well, you can do parallel data loading. There are, of course, also some weak points. If the business keys have not been defined, that's tricky because that will not enable you to build Data Vault, but there's a solution to that. I'll mention that in a sec. If you have 100 tables in your source system, in Data Vault, it will result in approximately 250 tables, but then well structured, well organized. And of course, when you want to extract data from your Data Vault to your dimensional model, you have some complex transformations to turn it into star schema snowflakes. But then again, that complexity is no longer moved from the source to the data mart, but from the source to the data warehouse to the data mart. So that's more convenient, so to say. So you still have the source data as is in your data platform, and from that moment on, you do the transformation for the consumption. So you can always explain where the data is coming from to accountancy organizations. Now, it's not suitable for the reporting tools, as I said, for multidimensional analysis, and not for ad hoc access by typical end users, not being data scientists. If you are very knowledgeable, you know how to program, you know Python and R, then you could dive into Data Vault and do your thing. But this is not for the lightweight end user. So they need the data marts based on the dimensional model. Even kijken hoor. And like I said, it could be automated. There is a tool on the market called Nippur that automates the realization of Data Vault by simply reverse engineering the source models. And that gives you a head start. Now, one of the things that we do a lot, and I go back for a second to this model, when we are not able to identify the proper business keys up front, one of the tricks that we automate sometimes is that we initially start with a lightweight Data Vault. We call that an HDA, an historical data archive. Is that we don't separate the hub from the satellite, but we put the hub information into the satellite. And later we can split it again. But that's a convenient way of reducing the amount of tables and still being able to capture history, still being able to integrate data more easily towards the dimensional model. So it's more a step in between. If you want to know more in detail, you can always contact me. We could elaborate on based on an example or take a little bit more time. But please be aware of the fact that if you're not capable of identifying the proper business keys up front, you will not start with this model, but you will start with what I call a historical data archive, a lightweight Data Vault implementation. I'm almost at the end of my presentation. So time-wise, we're doing well. Here is an overview of all the requirements that you want from a data model paradigm. And here you see the various models like the relational model, star model, snowflake model, and Data Vault model. And if you look through it, you can study that in more detail when you get the, you will all receive the slides, by the way, so you can look it up later. But as you can see that the star model and snowflake model, they are primarily used for reporting, for being used closely against reporting tools by end users, consumers, whereas the relational model and the Data Vault model are more being used to develop a data platform containing all the data all the time, where the Data Vault model or the historic data archive is better suited for capturing very large amounts of data in parallel, which is quite important nowadays since we see the amount of data grow overnight. The 3NF model is not fit for that. There you have cascading problems. You have to update this table first before you can update another table. In terms of Data Vault, that's not the case. That's less the case, so to say. Of course, you have to update the hubs first, but then you can parallelly load all the satellites from various source systems at once if you architect that properly. So the data load performance is fantastic. Yeah, and that's very bad when you talk about relational or star schema modeling. In terms of granularity, for instance, third normal form and Data Vault, they are good. All the details are in there. Star models, snowflake models, the dimensional models are not very good at it. Yeah. Visualization, on the other hand, is very easy when the star model is concerned. I touched all these things during my presentation. I would say, oh yeah, the data vault model allows to expand, same as the third normal form model. So it allows you to grow over time. So you don't have to architect your solution right at once, because that's not doable. Let me see in the chat, there is one remark. Oh yeah, somebody asked if could you download Facebook or Twitter data vault. Yeah, that's doable. We've been doing that. It's text data. Text data can also easily be captured in models like that. It's a very simple example, I think, because every Twitter account is unique. Eh? So you put the Twitter account in a hub, and all the messages you put in a satellite, and all the other stuff that you know, all the interactions with the messages, etc., the likes, the retweets, everything you know, you put that in a satellite. Good question, thank you. Now going back to my architectures, I'm going to show you some of the same representations of data architectures, and then I'll show you where to put these modeling paradigms. This one you remember from the beginning. I have this same picture in a more complex format. Here it is. It's the same picture, but this is how it looks when we build a data platform for a client. So it's more complex than you think. But again, on the left-hand side, you have the sources. Next to that, you have the data platform, all the data all the time in the yellow or green color. And as you can see, there seem to be different databases. That's not the case. But what we say, we typically distinguish source data warehouse and business data warehouse. And both source data warehouse and business data warehouse can be modeled according to the data vault paradigm. But the business data warehouse is where we integrate the data. I'll give you an example. Suppose you have 5 or 6 source systems, and you bring them into the data platform in this yellow column. Initially, you will load them in the source data warehouse layer. And if you look in that, you will still recognize the 5 source systems. Yeah? There are walls between them, if you like, because that's what we do. We just bring them to the platform, but we still respect where they come from, and we still recognize the source, where we derived it from. But what you want in the end is you want to model it and integrate the data, so no longer it's relevant from which source it came. You want it to reflect how the organization works. So I bring back my banking model, my banking example. This banking data model is typically what you model in the business data warehouse, where you bring everything together and integrate everything the way it should be integrated. So it no longer is relevant from which source system it's coming. That's a hard job. For that, you need these business keys properly defined. But if you've been able to do that, then data vault is the way to go. In the source data warehouse layer, you start with the historic data archive, the lightweight data vault. Now, typically the sources are modeled in third normal form, and the information delivery layer, that's where the data sets are prepared for consumption, what we call data marts. Those are dimensionally, oh, it's in Dutch, by the way, I'll change it. It should be dimensional, but those are modeled in a dimensional way. And there you can use tools like, now here they are, Power BI, Tableau, Azure, machine learning services, Minitab. It's being used nowadays still. Azure Databricks is doing well. Python, R, probably you all know these tools. But they all work very well on models like that. Although I must say that like R and Python, they also work very well on HDA and data vault kind of structures. Except you have to be aware of the fact that you have to combine and join a lot of tables. This picture is the same. It's just another representation of a data platform or a data warehouse, if you like, typically the constructs that organizations build. And also here I plotted the various modeling types. And as you can see here on the right-hand side, there is this statistical analysis referring to the data scientists, where we believe that they should be able to query the data vault layer. Whereas the others, like the e-commerce, the analytical applications, and the data marts typically are organized dimensionally. This brings me to the end of my presentation. Now, this was the first time to a community I don't know, and I don't know the background, I don't know the experience that you have. I'm sorry if it was too complex. I'm sorry if it was too simple. Nevertheless, feel free to ask questions or come to me, contact me later. I'm there for you to talk. I have plenty of time, and I'm very interested in what you're doing, what kind of projects you're starting, and maybe it would be nice to have a contact like that with people like you, so I can start to learn and understand what you're doing, and so better understand the community that's working with data, so we can tune this kind of presentation, because it was the first time, so we can tune this kind of presentation and make it better fit your needs. So you were the first group. I hope it. I hope you liked it. Parvati, maybe you take over. Is she still in there? No, I can't hear you. Why not? I didn't switch off my microphone, did I? Let me see. I'm hearing nobody. But I heard you at the start. Yeah.
Nobody is speaking, but you are not addressing us. You're waiting for somebody else, no?
Yeah, I was waiting for Parvati, so she's
Yeah.
Yeah.
But we can hear you, we can see you. Yeah, perfect.
Okay, thank you for that. So like I said, feel free to contact me later if you want. And by the way, you receive these slides via GitHub. Parvati is going to organize that.
Sorry,
Parvati?
Peter, I was
Yeah.
on mute or my microphone. Sorry for that, but thanks a lot. It was such a interesting presentation, specifically because you went into a lot of, I would say, depth in terms of how to think about this whole process, not just about the tools, which is great. Yeah, I'm sure that